guys, so I would like us to maybe work through this 2018 problem together for some extra practice. So you could find this, you can just Google the 2018 AP Statistics for a response question. We're going to look at number 3. We're going to do A and B, and then I'm going to change up part C. So let's read through this. It says, approximately 3.5% of all children born in a certain region are from multiple births. So 3.5% would be 0.035, okay, as a decimal. And of the children born in the region who are from multiple births, 22% are left-handed. So this right here, this was just the probability of the multiple births, whereas this statement just said, hey, they're giving you information. So of those who are from multiple births, so they're saying the probability that they are from multiple births, like they're giving you that piece of information, what's the probability that they are left-handed? So given multiple births, what's the probability of left-handed? And they said, hey, that is 0.22. And then it says, of the children born in the region who are from single births, 11% are left-handed. So this would be the probability who are not from multiple, so they're from single. So I'm just going to go do the complement. 11% are left-handed. So the first thing I'm going to do is just get those 3 pieces of information that they gave me. Then, once I have that information, I'm going to try to make either a tree or a probability like tree diagram or something there, a 2-way table to help me. I personally like the trees. So when I make my tree, I'm going to put the given information first. So the given information is whether or not they are from a multiple birth. Then the next one is whether or not they are left-handed. Let me move this. Okay, so I'm going to go fill in everything that we got. So we said the probability of multiple births, that goes right here. This one would be the probability of left-handed given that the multiple births has occurred. So right there, I know that that is 0.22. Then when I multiply this probability times this probability, I actually get the probability of multiple births and left-handed, which go ahead and multiply that out. I get 0.0077. So sometimes in this tree, they may give you the and they may give you this one. And if they ask you to find that, then instead of multiplying, I'd have to take over here divided by this one to get here. So it just depends on what they give you. And then they also said, given that we are not multiple, the probability of left hand, that goes right here. So then I can get the rest of the tree from kind of using all of these add up to 1. So if these add up to 1, then this is 0.965. This would be 0.89, 0.78, and then we can multiply through to get the rest of those as well. Okay, so go ahead and finish out that tree diagram. Okay, so now let's look at part A. Part A says, what's the probability that they would be left-handed? So left-handed occurred here and here. So I'm going to add those together, and part A would give me 0.11385. Okay? Let's look at part B. B says, and this was, sorry, I should have said this was the probability of left-handed. So part B says, what is the probability that they are from a multiple birth given that they were left-handed. Now, that one's crazy because this over here never gave me that. They gave me the probability of left-handed given M. So this is not in the chart. So we're going to have to go to our formula sheet, if you want to get that out. And we're going to go find that under Roman numeral 2 on the formula sheet. That's the probability of M and L divided by the probability of L. So that's kind of like my A and my B's from the formula sheet, but instead of A and B, we're using M and L. So now I do have this piece of information. The ands are in the very last column when we multiplied. So the probability of M and L was 0.0077. And the probability of L we just found in part A was 0.11385. So that gives me about 0.0676. So that would be part B. Okay, part C, I actually want to write out. I want to know, are the events multiple bursts and left-handed independent? So that's what I actually want for a part C to be. So not their part C. Their part C is going to come from the part 2 of this unit. So we don't know how to do that yet. So this part C, I want to know if the events multiple bursts and left-handed are independent. So I want to know, in general, if A given B is equal to the probability of A, then they are independent events. If they are not equal, then they are not independent events. So instead of our A and B, we're going to do the probability of M given L. Is that equal to the probability of M? Or you could have switched the variables and said is the probability of L given M equal to the probability of L. So either way, you could do that. So let's say that we wanted the probability of M given L. Well, we just got that in part B. That's 0.0676. Is that equal to the probability of multiple bursts? So multiple bursts was 0.035. It is not, so these are not independent. Let's say that I went over to this one instead. So what's the probability of L given M? So the probability of L given M we said was 0.22. And is that equal to the probability of L? And we found that in part A, which was 0.113-ish. And those are not equal. So again, I get the same conclusion, which should happen. So these are not independent events. Okay, so I hope that problem helped a little bit to go through as you are studying. And there you go.